Alright, today under this study, we'll be treating the topic exponential equation. And when we talk about exponential equation, we say we make the bases the same, cancel out the bases and equate the powers, or make the powers the same, cancel out the powers and equate the base. Now, in some cases, you are expected to make the bases the same. Once you succeed in making the bases the same, just like this example, you now work out the powers by cancelling out the bases. Now, citing at these examples that we have here, this is the first example. We say 4 raised to the power x equals to 8. And of course, you know, as indices implies, we are expected to make the base the same. So here, the common base for these two terms is 2. Okay, now we have 2 raised to the power 2, of course, is 4. And then 2 raised to the power 3 is 8. And since this 4 was having an original power of x, it multiplies the new power of 2. And then we now, since the bases are the same now, we now cancel out the bases and equate the powers. Equating the powers, we have 2 times x equals to 2x equals to 3. Okay, now we have x equals to 3 over 2. How do we get that? Here we need to make the x subject to the formula by dividing both sides by the quotient of x, which is 2. Okay, these 2 will cancel these 2. So x is what is left here, and we have 3 over 2 here, which is also the same thing with one whole number 1 over 2. Okay, now the second question says 9 raised to the power x plus 2 equals 27. Now at this point we also have to make sure that the bases are the same. And now the common base for 9 and 27 is equal to 3. And of course 3 raised to the power 2 give us will give us 9, and 3 raised to the power 3 will give us 27. So the already existing power of 9 will multiply the new power of the new power, which is 2. So since the bases are the same now, we can now cancel out the bases and equate the power. Now equating the powers, we have 2s equals to 2 times s equals to 2s, and 2 times 6 equals to 4 equals to 3. Alright, so we have to collect like terms at this point. We have 2x equals to 3 is already here. Now 4 crossing the equality sign becomes minus 4. And then the next is 2s equals to 3 minus 4 is equals to minus 1. So we have x equals to, at this point, how we got minus 1 over 2 is we need to get the x only. So getting the x, we divide both sides by the quotient of x. Quotient of x here is this 2. So we cancel out the 2. And then what we are left with is minus 1 over 2. Now at this point we have question number 3. And here the question is 3 raised to the power 2 minus 3x equals to 81 raised to the power 1 minus x. Okay, so at this point we also have to make the base the same. Now making the base the same, we have this already 3, and of course 3 raised to the power 4 will give us 81. So the new power will multiply the already existing power. This one is still the way it is. So at this point we find that the bases are now the same. We cancel out the bases and then equate the power. Okay, equating the power, we have 2 minus 3x equals to 4 times y is equals to 4, and 4 times minus x equals to minus 4x. So we need to collect log terms at this point, which is minus 3x minus the next x here is this one, which is minus 4 crossing becomes plus 4 equals to 4 is already here at the other side of the equality sign. Okay, then 2 crossing becomes minus 2. Alright, we now have minus 3x plus 4x is equals to x. You're owing 3, you got 4. When you pay the 3, you're owing, you'll be having 1. That's positive 1x, okay? Equals to 4 minus 2 is equals to 2. That is it for this one. So the fourth question now is 1 over 4 times 16 raised to the power p equals to 8 raised to the power 2p. Okay? Now we have, at this point, find out that this one is having a fractional term. These ones are not having any fraction. And look at this is the only fraction. The only fraction here, the only numerator here is just 1 over. And of course, we can easily change this 1 over to become negative index. Okay, you can watch the previous videos for you to get better understanding on this very one. Okay, so here we have 4 raised to the power x equals to 4 raised to the power minus 1 times 16p equals to 8 raised to the power 2p. So we have to make the base the same at this point now. The common base for all these ones is 2. So we have 2 into bracket minus 1. Okay, that's 4 raised to the power 2. Okay, into bracket minus 1 times 2 raised to the power 4 is equals to 16. So we having already 16 power of p, which is equals to 2 raised to the power 3 into bracket 2p. Okay, 2 raised to the power 3 is equals to 8. Alright, now that the bases are the same at this point, we will not cancel out the base just like that. We will look for a way to make sure that what we have at this side of the equation is just one term, and what we have here is just 1 point. Okay, so what at this point what we have is 2 raised to the power 3 bracket 2p, which is just one term at this other part. So what we have to do is take one of the bases here, which is 2, and then apply the multiplication law, which is we have to change this. Instead of multiplication, we now convert it to power of plus. So we have 2 times minus 1 is equal to minus 2, and then because of times we put plus, and then 4 times p is equal to 4p, equals to 2 raised to the power 3 times 2p is equal to 6p. So now that the bases are the same and we have single term on both sides, what we have to do is to cancel out the bases. Okay, now having cancelled out the bases, what we have to do now is to equate the powers. So equating the powers, we have 2 minus 2 plus 4p equals to 6p. Okay, we have to collect our terms at this point. We have 4p, 6p crossing becomes minus 6p, and then we have minus 2 crossing becomes equals to 2. All right, so we now have 4p minus 6p. You have 4, you bought 6, you'll be owing 2. Owing is debt, that's minus 2p equals to this 2. Now at this point, the p is equals to 1. How do we get it? We have to divide both sides by coefficient of p. Coefficient of p is this thing now, which is coefficient of p here is minus 2, okay? Minus 2, okay? All over minus 2. So these 2 will cancel these 2, minus will cancel minus, okay? 2 will cancel 2 here, 1 here. So what we have here is what? 1 over minus 1. 1 over minus 1 is same thing with minus 1 over 1, which is equals to minus 1. Okay? All right. So at this point, the next question is question number 5. 8 raised to the power x equals to 64 raised to the power 0 equals to I think this is not, there's no equal to this not, there's no power here, so we have equal to 0. So we have 8 raised to the power s equals to 64. Of course, at this point we cannot make the base the same. There's no base that will be raised to power anything to give you 0. So what we do is to take this figure over to the other side of the equation. Okay, we now have 8 raised to the power s equals to 64. Then here we have 8 raised to the power s equals to 8 raised to the power 2. Of course, 8 raised to the power 2 is equals to 64. So now that the bases are the same, we cancel out the bases and equate the power, which is s equals to 2. Okay, that's it for that one. So at this point, the next question here is question number 6, where we have 8 raised to the power x plus 1. 8 raised to the power s plus 1 equals to 0.25. Okay, now at this point, looking at this 0.25, we don't work with decimal. Okay, we convert the decimal to fraction. All right, so at this point we have this is see what it is. Converting this into fraction, we have 25 is the significant number after the decimal point, which is 25. So then we put over 1, okay, over 1. Then we move from the decimal point 1 2. That 1 2 determines the number of zeros that will be here. That is 2 zeros, which is equals to, if you write this one down, it will be 1 over 4. 25 into itself is 1. 25 here is 4. So at this point, this 1 over 4 is same thing with 4 raised to the power minus 1. And of course, we don't need to work with this fraction since we have 1 over. We convert it to negative index. So that what we have next will be plain numbers that will just make the bases the same and equate the powers. Okay, so at this point, what we have is 2 raised to the power 3 is equals to 8. Then the already existing power will enter to multiply this new one. We now have 2 raised to the power 2 is equals to this 4. This minus 1 enters to multiply the new power here. So at this point, we now have, since the bases are the same at the both sides of the equation, we now cancel out the bases and then equate the powers. At this point, we have 3 times s is equals to 3s. 3 times 1 is equals to 3, equals to 2 times minus 1 is equals to minus 2. So at this time, we have to collect our terms. We have 3s is already here, equal to minus 2 is already here, plus 3 crossing becomes minus 3. Okay, 3x equals to minus 3 minus 2 minus 3. You're owing 2, you owe 3, and you'll be owing 5. That's minus 5. Okay, now at this point, we have to divide both sides by the coefficient of s. Coefficient of s here is 3. Okay, and then we divide both sides by this 3. 3 will cancel 3 here. So s is left alone here, equals to minus 5 over 3. Or, how many 3 are in 5? It is 1, 1, remainder 2. All over that same 3. Okay, of course, the minus is still there. Now, the next one here is 7th question, which is 1 over 4 raised to the power s equals to 2 raised to the power minus s all over 2 times 64x. So, at this point, Looking at this question, this one is a fractional term. Okay, this division is another law on its own. So we need to make sure that we work on this division separately. So what we have next is okay, now we can still use the other method of cross multiplying. Okay, now looking at this is a fraction, this is another fraction, so use the method of cross multiplication. Now 1 times 2 times 64 raised to the power s is equals to the same thing with this, which is what we have here, as in this will multiply this and this will multiply this. Okay, this is just okay here. So the next thing we treat is 4x 4 raised to the power s. We also multiply this. Okay, that is this 2 raised to the power minus s times 4 raised to the power s, that is, which is what we have here. Okay, all right. So at this point we need to make the basis the same. Okay, that's just what to work on now. Of course, the common base here is base 2, which is 2 raised to the power 1 times 2 raised to the power 6. 2 raised to the power 6 is equals to 64. We have the s already there, multiplying, we have 6s. So here we have 2 raised to the power minus s times 2 raised to the power 2 is equals to 4, and s is already there. So now the bases are the same, but we cannot just cancel the base now because the base at this side is more than one base. The same thing with this place. So we need to make sure that we have just one term of base and one term of base on the both sides of the equation. So we now apply the multiplication law here by taking 2, which is one of the bases, and then we have power of 1 here. Because of times, we now put plus 6s equals to 2 raised to the power minus s plus 2 raised to the power x. Okay, now this plus is for these times. All right, now the bases are the same on both sides, and it is just one single base. We cancel out the bases. Okay, now the next thing we should treat now is equating the bases, equating the powers, which is 1 plus 6x equals to minus s plus 2x. Now we now have to collect like times here. 6x and minus s crossing becomes plus s, minus plus 2s crossing becomes minus 2s, equals to 1 crossing becomes minus 1. So 6s plus s equals to 7s. 7s minus 2s equals to 5x, which is equals to minus 1. So at this point, we have to divide both sides by the quotient of s. Quotient of s here is this 5. Quotient of the same 5 will cancel here. We have 5 will cancel 5. S is left alone, which is equals to 1 minus 1 over 5. So the next question is question number 8. Okay, here we'll be treating say 5 times 25 raised to the power x minus 1 equals to 625 raised to the power s divided by 125 raised to the power 2 minus 3x. Okay, so at this point we now have 5 raised to the power 1. Of course, there's invisible 1 here. The reason why I put it is for us to apply the law and also know that there's 1 as the power. Anything raised to the power 1 is still itself. Okay, here 25 raised to the power 5 raised to the power 2 is equal to 25, and the already existing power will enter to multiply this new 2. Okay, equals to 5 raised to the power 4 is equals to 625, and then raised to the power s divided by, of course, that 4 times s is equals to 4s divided by 5 raised to the power 3 is 125. Okay, then all raised to the power 2 minus 3x. Okay, close the bracket. Now at this point, the powers are the same on both sides, but then we are still having something inside the bracket to work out. Okay, now considering what the things inside the bracket, this is what it is, and then here we have 5 raised 2x 2 times s equals to 2s, and 2 times minus 1 is equals to minus 2. This is still 4s. 3 times 6 is equals to 6. 3 times minus 3 is equals to minus 9x. That's 3 times minus 3s equals to minus 9s. Here now we have the basis, the powers have nothing else to work on. So we now apply this law to have single terms on both sides of the equation. Now we have more than one term here, which is 1, 2, and the other side 1, 2 as well. So taking one of the bases, we apply multiplication law by adding the powers. We now have 5 raised to the power 1, because of times we say plus 2s minus 2 equals to 5 raised to the power 4s. Because of division, we say minus. And I have to put everything here in brackets so that this minus will affect both this 6 and also this minus 9 to change the sign of all of them. So we now have on the other part, before this other part, since the base are the same now and single, we can now cancel out the bases and equate the powers. So we now have 1, which is this one here, plus 2x minus 2 equals to 4s minus times 6 is equals to minus 6, minus times minus 9s equals to plus 9s. Okay, now the collecting like times, we have 2x, 4s crossing becomes minus 4s, 9s crossing becomes minus 9s. equals to minus 6. Minus 6 is already here on the other side of the equation. Now 1 crossing becomes minus 1. Minus 2 crossing becomes plus 2. And then here we have 2s minus 4s is equals to minus 2s. And minus 2s minus 9s is equals to minus 11s, which is equals to minus 5. Okay, now how do we get minus 5? Minus 1, minus 6 minus 1 is equals to minus 7. Minus 7, you're owing 7, you got 2. When you pay the 2, you'll be owing 5. That's minus 5. Okay, so at this point, we have to divide both sides by the coefficient of s. Coefficient of s here is equals to minus 11, and then all over minus 11. Minus will cancel minus, 11 cancel 11, and then plus minus will cancel minus here as well. So s, we are left with s equals to 5 over 11. So at the other part, what we have is number 9, which is 1 over 125 raised to the power s equals to 0.04. Okay, all raised to the power minus 2. So at this point, we consider this decimal to convert it to a fraction. And then, of course, what we have here, the significant number here is equals to 4. Okay, so put down the 4 all over 1. And then how many number of 0 is determined by number of times we move to cover the numbers here from decimal points. That is 1, 2. Okay, that's 2 zeros. All right, all raised to the power minus 2. Now, at this point, we can cancel out what we have here. Okay, so cancelling out what we have here, 4 into itself is 1. 4 into 100 is equals to 25. Okay, so what we now have is 1 over 125. Okay, all right, so what we have here is 1 over 125, which is this one raised to the power s, equals to this is now 1 over 25. So at this point, this is what we have here is 1 over 1 over. So we change this 1 over to negative index. Okay, this 1 over also to negative index. 125, 125. The x there, when this minus multiply this s, it will be minus s. Okay, this one is having minus 1. Since anything this is raised to power invisible 1, so that's why we put 1 here. So at this point, we now try to make the base the same. The common base for 125 and 25 is equals to 5. So 5 raised to power 3 is equal to 125. 5 raised to power 2 is equals to 25. Okay, now all of them multiplying their already existing power. So at this point, since the bases are the same, we cancel out the bases. Okay, and then we equate the powers, which is 3 times minus x is equal to minus 3s. Okay, then 2 times minus 1 is equal to minus 2. And then dividing both sides by coefficient of s, s will be left alone, equals to minus 2 over this, minus 2 over minus 3. Okay, and of course, this is something with x equals to 2 minus will cancel minus, we now have 2 over 3. All right, at this point, this is the 10th question. Here we have p raised to the power 1 over 3 equals to 5. And then we have, if you look at this, there's no way we can make the base the same, and there's no way we can make the power the same either. So what do? We try to look for the way. Well, our target is to make sure that we have only p left alone. So what can we do to remove this power of 1 over 3? When you multiply 1 over 3 by 3, this 3 will cancel this 3. So what is left is what? 1, 1, which is 1, and which is what we have here. So we multiply this power by 3 and also do the same thing on the other side of the equation to balance it. So we now have p raised to the power 1 equals to 5 raised to the power 3 is equals to 125. So p is equals to 125. All right. So the next thing we should treat is question number 10, which is 2 raised to the power 2s minus 1 divided by 8 raised to the power minus 1 equals to 1. So at this point, the common base can also be 2, even this one. And of course, know that anything raised to the power 0 is equals to 1. So since all this one can have common base of 2, you can give this one also a common base of 2. So what we have now is 2 raised to the power 2s minus 1. Because of the division, we say minus. Okay, we are taking one of the bases here. Okay, now taking one of the bases, of course, 2 raised to the power 3 is equals to 8. 2 raised to the power 3 is 8. So taking one of the bases, we apply the division law, which is minus here, subtraction. Okay, so what we have now is 2 raised to the power 2x minus 1. Because of this thing, we put minus 3 times minus 3 is equals to 3 times minus 1 is equals to minus 3. So equals to 2 raised to the power 0. At this point, since the bases are the same and on both sides of the equation, we cancel the bases and equate the powers. So we have 2x minus 1 minus times minus equals to plus equals to 0. So what we have now is to collect like times. We have 2s equals to 1, minus 1 crossing becomes plus 1, and 3 crossing becomes minus 3. So what we have next is 2 raised to the power s, 2s equals to minus 2. Of course, 1 minus 3 is equals to minus 2. So we divide both sides by the quotient of s here now, which is 2, 2. Cancelling out the bases, s is equals to minus 2. This 2 will cancel here, 1, 2 here, 1. Minus 1 over 1 is equals to minus 1. So at this point, we now have the 11th question, which is 9 raised to the power 2s plus 1 equals to 3 raised to the power 4 bracket minus 2 all over 3 raised to the power x bracket s minus 2 all over 3 raised to the power x. Okay, now looking at this question, just like the one we treated before, this is a fraction. So when we have a fraction, what we have to do is to cross multiply. This is same thing with over 1. Okay, now cross multiplying, we have this one multiply this will multiply this. So this times this is this times this, okay? And then this times 1 is still itself. Now, at this point that we have succeeded in doing that, we have to concentrate on the basis now to make the base the same. Now, making the base the same, this 9 can have the common base, which is 3 as this ones. Of course, 3 raised to the power 2 is equal to 9. And the already existing power will enter the bracket to multiply the new one. Now, times 3 raised to the power x, which is this one. And then this one, we open the bracket. 4 times s is equal to 4s. 4 times minus 2 is equal to minus 8. Now, at this point, we have 3 raised to the power 2 times 2s equals to 4s. 2 times 1 is equal to 2. Okay, now, we apply the law here. This is times. Because of times, we not say power of plus. Okay, so power of plus will give us plus x, that is plus this x, equals to 3. This is still the same thing. Now, since the bases are the same on both sides, what we have to do is to cancel out the bases and equate the power. So we have 4x plus 2 plus s equals to 4s minus 8. So we now have 4, collecting left times 4s plus x, then minus 4s equals to minus 8 minus 2. Okay, which is this will cancel this. Okay, 4s minus 4s is off. We have s equals to minus 10. Okay, so here we have the next one there to be y raised to the power 2 equals to 16. And then y raised to the power 2 equals to 4 raised to the power 2, of course. We have to make the base the same. Okay, all right, this is another question. Like, if you cannot make the base the same, you have to make the power the same. So since we cannot make the base the same here, we look for a number that we can raise to the power the same thing with this. And then we now cancel out the powers at this point and then equate the base.